In this first video covering material for Chapter 4, we're going to look at an introduction to scatterplots. Back in our earlier chapters, we discussed categorical data compared to numerical data. In Chapter 4, we're going to add another type of data, which is bivariate data. We have bivariate data collected when two numeric variables that may be related from one individual are studied. And when bivariate data are collected, the display of choice is the scatter plot that will allow us to study the relationship. So some examples for bivariate data might be a person's age compared to how much their monthly car insurance premium is, or the amount of fat versus the amount of calories in a snack. You would expect as the amount of fat goes up, so would the amount of calories. Another example would be the hours you study for a test versus your grade on a test. When we have this bivariate data and we put it into a scatter plot, we can describe three specific properties for this class. The first property is the trend, and we'll say the data is either showing a positive trend or a negative trend. If the graph goes up from left to right, it would be a positive trend. So scatter plot 2, this trend line, this would be a positive trend. As the x variable, or the explanatory variable, increases numerically, the y variable, or the response variable, increases numerically. So scatter plot 2, this is the city miles per gallon of a car compared to its highway miles per gallon. A car with low city miles per gallon probably also has low highway miles per gallon. A car like a Prius that has a higher city miles per gallon should also have the higher highway miles per gallon. On the other hand, if the scatter plot goes down from left to right, let's say it has a negative trend. Sodium content in a snack compared to its consumer report rating. Typically, higher sodium levels are bad for you, so as your sodium level, as your X goes up, your rating would go down to be less and less favorable. So we have snacks with low sodium here, they have a very high rating, and then your snacks with your higher sodium content, they have a lower rating. Another way we'll describe scatter plots is with strength. In this class, we'll describe a relationship in a scatter plot as either strong or moderate or weak. And these three scatter plots display each of those. We have a strong relationship, a moderate relationship, and a weak relationship. When your dots are very tightly clustered together in a linear pattern like they are in scatter plot 1, we say it has a strong relationship, a strong correlation. But as your dots begin to scatter farther and farther vertically, up and down, it becomes moderate, and then as they scatter even further, it becomes weak. Scatter plot 3 would be my moderate strength. I can still see the linear pattern, I can still see a line going through this data, but it is more scattered than what we see in scatter plot 1. And scatter plot 2, we would say is weak because there is even more vertical scatter here, less of a linear pattern. And if we look at the variables that we're studying, it kind of makes sense. Scatter plot 1 is the relationship between your forearm girth and your bicep girth. Well, that should be a strong relationship because your forearm muscles, your biceps, they're very close together on the body. So I would expect that as your forearm gets larger and larger in girth, it's bigger around, your biceps would also get larger and larger. You're working out your arms. Scatterplot 2 is weak. That's a person's age as well as their bicep girth. Well, age doesn't have to affect your biceps. You can be 20 years old and have huge biceps or have small biceps. And you can be 50 years old and have huge biceps or small biceps. So there's a weaker relationship there. And then Scatterplot 3, it's a moderate relationship. It's your calf girth, the distance around your calves, versus the bicep girth, the distance around your biceps. So we would expect some relationship here, that as your calf girth grows, your bicep girth would also grow. But because those muscles are farther apart in the body, they won't be as closely related as your forearm and your bicep. It's like those people you see who they skip leg day. They're huge up top, but they have really skinny legs. So there's a moderate relationship with those two variables. The last characteristic that we'll discuss for scatterplots is the shape. And in this class, we're only going to use the classifications as either linear or non-linear scatterplots. If you see a clear curve, like we do in Scatterplot 1 or Scatterplot 3, we'll label the relationship, the scatterplot, as nonlinear. But if we see a fairly straight line, it doesn't have to be a perfect line like this in Scatterplot 2, but like we saw above, it's a pretty good line. We say it is a linear scatterplot. Up above, I saw some pretty good linear trends, so these could be classified as linear. For the purposes of this class, we are only going to focus on linear scatterplot. So it's going to be important that you look at your scatterplot and make sure you see a linear relationship. If it's a non-linear scatterplot, if there's a clear curve, we're not going to examine it statistically. We only want to focus on these linear relationships. Just to go through the variables quickly, Scatterplot 1 is the year compared to Medicare expenses. That has gone up, but not in a linear pattern. Scatterplot 2, the linear scatterplot, that's temperature in Celsius versus temperature in Fahrenheit. There's a direct relationship there. And then Scatterplot 3 was the month versus rainfall in Napa Valley. So this first month, rain is high, then it's lower the second month, even lower the third month, lower and lower until it hits these months later on in the year, then it begins to increase up again. When discussing scatterplots, we'll talk about the trend or direction, the strength, and the shape.